Hi guys, in this video we will explain what is an OSI TCP/IP model. OSI and TCP/IP model, basically these are networking models, and if you are interested to know each and every detail about these TCP/IP model and OSI networking model, then watch this video till the end. I will explain the history of these two models, how they were developed, what is their requirement, what are their benefits, and how each and every layer work together. So if you want to get to know all these details, then you have to watch this video till the end. Right. So first of all, what is a networking model? So I'm going to explain with a few examples here. Let's say if you have one computer here, right? Okay, and another computer here, and another computer here. So if these devices needs to talk to each other, then you need some certain rules and regulations and standards and protocols for these devices to talk to each other. So those protocols basically are very important. Otherwise, if there is no standard or something, so then you cannot make these devices to communicate with each other. There should be some kind of standard. So, so what happened is historically, all these networking companies like vendors, different vendors, for example, IBM, they developed their own networking model. And then there was some other companies, some other vendors, for examples, they developed their own networking models. And then they have what happened is only hardware produced by these vendors, for example, this is IBM and this is some other vendor. And what happened is basically any hardware produced by these vendors, they were only able to talk to each other, right? But let's say if company A, this is IBM, company A, company B, if company B buys company A, and you have to merge these two networks, then it was not possible. So that's why what happened is they started to develop a standard networking model, which was called in the beginning as an OSI model, right? So OSI model was originally produced, and this was an effort by ISO, International Standard Organization, which used to be publishing some standards for these networking models. And then they developed this ISO model initially first. And later on, this TCP/IP model was an open standard, and this was developed as this middle one, where we have network link layer, internet layer, transport layer, and application layer. And in after that, it was mature to have these two additional layers. Link layer was divided into data link layer, physical layer, network layer, transport layer, and application layer. So in order to understand these two networking model, I'm going to give an example from daily life. Let's say um, here is a person, right, or a place or a house or something, and here is the destination. And you want to, for example, send a letter or a package from location A to location B, right? So this is, for example, you, or let's say you want to send a packet to your friend in, you are based, let's say, in city London, right? And this is, let's say, a different city, New York, in a different country, right? Okay. And you want to send a packet from London to New York. So similarly, let's say this is a computer A in London. You're sitting in London, right? Okay. And you want to access a server which is based in a web server, for example, in New York, right? So in terms of here, it could be a letter, a simple letter, or it could be, let's say, a one big parcel, or it could be, let's say, 100, a packet of let's say a package of 100 packets, like you want to send So in this case, this TCP/IP application layer, this is being done as part of the application, because in the TCP/IP model, this layer or this piece of work is called application layer, right? Because as an application layer, you'd know what letter is, what are the contents of this letter, or how the other person, destination person, is going to understand your letter. What language you have written. Probably you have written in English, or you have written in French, or whatever. So this is called application layer, right? So the other layers underneath layers, they don't need to understand what you are writing, the physical layer, data link layer, transport layer. They don't need to understand what kind of letter you have written, what are the contents of this letter, or what language this letter has been written. So this is called yourself, and you're writing an application. You're writing an application or a letter, and you're supposed to send it to New York to your friend, right? So this is, we're still on the application layer, and still in the next layer is a transport layer. As a transport layer, you are still consider it yourself in the transport layer, right? What transport layer does is, let's say it depends if you have 100 letters or 200 letters that needs to be sent to the same person, or 100 different type of messages. You might want to send to your 10 of different friends. You might have one letter for this friend, one letter for this friend, one letter for this friend, and one letter for this friend, right? So this is yourself. You decide, so which letter should be sent to which. And if you want to, let's say, break down a big package into 20 packages, small packages, and you send one by one to each destination. Okay, so this is the function of the transport layer. Similarly, in networking model, what transport layer does is it gets the whole package from the application layer, and then it breaks down. Let's say this is the whole package it got from data, and then it will break down each package into smaller packages, and it will number those packages. And let's say package number one is it's the same package, big package, but divided into small segments of those packages. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it will be sent to the same order into the destination side. Okay, so that's the function of transport layer. It breaks down the whole package, and it can securely transfer. Or so there are two different type of services. One service is, for example, you think, okay, I don't care if one of the packages, 1, 2, 2, 3, 4, 5, 6 in the sequence, if it gets lost, I don't care, I just keep sending the packets to the destination. But this is called UDP, right? And the other one is, if you want to secure, make sure you get an acknowledgement once you send a packet part one, and you get an acknowledgement back. Okay, the destination side say, oh, I write you back. Okay, I have received the packet one. Please send me the packet two. And the packet number two, segment number two is sent of that whole package, and segment number three is sent into the whole package, right? So this is called a secure transmission of the packages. So this is called TCP in terms of networking model, right? So now consider the third layer, which is the network in the networking model is called IP layer, right? IP layer. So what is the function of IP layer? Still in the same example of, here you are, right? Okay, and here is your destination. So you write the source, where you are sending this from, source, right? Source of this letter, and the destination of this letter, right? Okay, destination. Similarly, in networking model, every location has its own IP address, a unique IP address, right? A unique IP address. So there are two different types of IP address. One is private and one is public. But we're not going to discuss the details of those IP addressing for now. So let's say computer A has IP address 1.1.1.1, and this has 2.2.2.2, right? So you are supposed to send from source A to destination B. So what you do is basically you take your parcel to the local transport company, or the postal company, right? So you hand over this packet to your local postal company, So what postal company will do is basically they will try to look for the destination. If it's in New York, it might need to go to the central hub, right? Distribution hub, okay? And then it will be going from that local destination to this central destination, and then the central destination probably will send it to the the destination country, and in the destination country they will send it to the local distribution center probably, and then they will see the local distribution service probably have all those local addresses of that street, house number, and everything, and then they will deliver it to the the original destination of that package. So this is called IP layer, like where we have IP addresses. In terms of networking model, here is, let's say you send your packet to the LAN router, right? This is your router, which knows all the destinations, the outside destination in the world. So in order to send it to, let's say, it says send it to, first of all, to the next hop, which might be the water gateway, somewhere in the country, the ISP gateway, and then from there it probably will send to another router, and then from this router might be the local router, in that ISP, which knows all the destination of those routers, so it will send it to that destination. So this way the packet is transferred. This whole functionality of IP and IP routing is part of the network layer. And when it comes to the next layer, which is data link layer. So what's the function of data link layer? Data link layer is a local layer, like it works at a layer 2 level. So for example, in this still in this example, the local company, destination company, the post office, they knows all the local addresses in that street. Probably it might be a town center or something. They know all the house numbers, postal codes, and everything. So they will search that local address and send it to the local house, where the original destination is. So in terms of networking, this is called the MAC address. So the MAC address is basically local to the LAN. So the router, the gateway router, when it receives the packet from the destination, it will check all the local MAC address, which are, the local destination. So this could be a different, probably it could be a physical, it could be wireless, or it could be anything. So then in this way, the packet, the data link layer is transferred to the destination computer. So this is called layer 2 communication, right? So I'm just going to give some benefits of this. What are the, for example, so similarly, you see here are the physical layer is basically that work on the bits and like maybe transmission medium, physical, wireless, or anything. So data link layer will work on the MAC addresses, network layer will on the IP address, transport layer will work on the ports numbers, like it assign the port number and everything, and the original data from the application layer. Similarly, in the application layer, the functional description, as you can see here, the application provides the interface and the application to the protocols which are only meaningful the application. Presentation layer and a session layer, which is not anymore discussed in this. And there are some examples of these different applications, HTTP, HTTPS, and different protocols at the application layer. So TCP, UDP is the transport layer, IP layer is the router, work on mainly on the routers, and in the networking LAN switches and all those, they work on the layer 2. So this is a less complex standard interfaces, easier to learn, easier to develop, multi-vendor interoperability, modular engineering. So these are some basic benefits of this layered approach. So this is how, guys, this TCP/IP layer structure was developed. Originally was OSI model, and then later on it was developed as a TCP/IP model. I hope you like this video. Please hit the like button. If you have any questions, then please reach out to me. Thank you.